Hi, in this video we're going to talk about delayed durability. It's a feature I wish I had when I started consulting because when you do consulting, a lot of the time the requirement is performance tuning, and it's very easy to give read performance, but it's significantly harder to give write performance because the number of options that are available are limited, and almost always the solutions are fairly expensive, requiring infrastructure level changes which most companies are not comfortable with, things like storage optimization, etc. And the thing about delayed durability is it gives you some amount of leeway in terms of how you approach write operations inside SQL Server. And the best way to understand that is to first really have a look at how things are being done now, and then see how delayed durability improves that situation. Now, a transaction, as you know, has to be consistent, has to be isolated, has to be durable, has to be atomic. And in order to ensure that a lot of the stuff that you do, especially with regard to DML operations, are synchronous, which means that when you commit a transaction, the data has to move from the log buffer, which is a portion in the RAM where the transactions are maintained, and written to disk. And then once it's written to disk, only then do you get the control back to the transactions. So in many ways, it's similar to the way that you could think of database mirroring, where we have the secondary who is always committing the transaction first before the primary releases control. So what happens here is, because of this synchronous nature, the transactions throughput is purely dependent on the speed of the disk of the transaction log file. And naturally, if the disk isn't able to keep up, there will be some latency in terms of how quickly the write happens to disk and how quickly the control is released back to the to SQL OS. Now, this is obviously a challenge when you have highly transactional database systems with millions of inserts, updates, and deletes happening per second. So for low volume transactions, you'll not really see much of a difference in terms of performance. But if you're having a highly transactional system, delayed durability is something that you definitely want to consider. Now, in delayed durability, what happens is your database basically has a setting that allows you to go ahead and control which transactions are written synchronously and which transactions are written asynchronously. Now, when you say asynchronous, what happens is that the transaction is not immediately written to disk as soon as you commit. Instead, it is written to disk under three different conditions. So this is the option that you want to be changing, which I'll explain in a minute. Now, the first scenario with delayed durability is when you say that it's delayed durable, the transaction remains in the log buffer until you actually have another transaction which needs to be committed anyway. So essentially what happens is that you can look at your queries and say, these are the 5 queries I want to be synchronous, and these are the 5 queries I don't want synchronous. And as long as the log buffer has only asynchronous transactions in them, they'll continue to remain there. But as soon as you fire off a query that requires a synchronous transaction, like maybe order processing or payment, anyway the write has to happen to disk, and at that point whatever is there in the log buffer will be pushed to disk and written successfully. The second option is basically a procedure called SP flush log, which allows you to manually fire off a write to disk, and this also is something that I have not really seen being used a lot, and the reason for that is because the log buffer is basically just 60 kilobytes and it's fairly easy to fill it up under normal workloads. So that shouldn't really be an issue, because the third reason why a synchronous operation will be pushed to disk is when the log buffer becomes full. So before you even use SP flush log, typically what you will encounter is there will be some kind of committed transaction that needs to be run anyway, or the log buffer becomes full and the data needs to be written to disk. So I usually find that between these two, most of the scenarios that you encounter are taken care of. But again, if you want some more control, like maybe you want to persist the data before you do some maintenance activity, you still have the option of using SP flush log. Now, delayed durability, again, as you can see here, has 3 different options. The first one being disabled, which means that all transactions are treated as synchronous transactions. The second one being allowed. In allowed, what happens is that you need to explicitly communicate to SQL Server whether the transaction is delayed durable on or off. And the last option is basically forced, in which SQL Server goes ahead and treats all transactions as asynchronous. Now, in order to see the behavior, what I'm going to do is I'm going to go ahead and set the database right now to disabled. And as you can see here, we've got the wait type for 2 of the common wait types that we encounter. You can see here that I've got Writelog, which is currently at this value, and this is the log buffer. Now, delayed durability doesn't really improve the performance of any log buffer wait stats, because the log buffer being in the RAM is already pretty fast and responsive. It's the write log, which means writing to the transaction log file, which usually lags behind. So I've got Ostress up and running. I've got a procedure that I want to run. It inserts a row into a table, and right now I'm simulating, as you can see, 500 users running the request 100 times each. So when I run this, what we're going to see is I've already taken the output of the wait stats, and let's just wait for this query to complete, and we'll compare the wait stats. So you can see this query took about 13 seconds to complete. So I'm just going to go ahead and compare the stats here. So you'll see there's really not much of a difference in terms of the log buffer. They remain fairly consistent, but you'll see that there is significant change in terms of the time taken for the write log, which proves that our transaction log file is definitely not able to keep up with the requirement. So in the interest of consistency, I'm going to run this one more time and make sure that we've got predictable behavior. Nothing like auto growth, etc. coming into play. So let's give it a second, and yeah, you can see here it took about 14 seconds once again. So roughly at this moment we can see that the execution time, the query performance is roughly about 13 to 14 seconds, and you'll see that we don't really have much of a difference in terms of log buffer, because you'll see that even though the log buffer time has increased, the actual the amount of time in milliseconds is not significant. Whereas if you look at the write log, you'll see that there's a significant difference in terms of performance. So at this point, the only thing left to do is go ahead and change delay durability here to forced and run this query again. So let me just go ahead and run this really quick. So this is what it looks like before we ran the query, and gonna run the query again. And now you can see that it took only 10 seconds. So if I run this wait stats again, you'll see that basically we don't really see much of a difference now between the write log behavior before and after. If you see, the number of waiting tasks is only 6 more than what it was before, whereas previously it was in tens of thousands. And this is kind of what delay durability does for you. It basically reduces the number of times you hit the disk, and therefore reduces the amount of time you wait for the disk to respond back to you. Again, in the interest of consistency, let's go ahead and run it one more time. So you'll see that we brought down the execution time from 14 milliseconds to 10. And simultaneously, we also see that while this execution time is reduced from 14 to 10, the amount of time that we spend waiting for the disk to respond has also significantly reduced. So you'll see again, it's about 10 seconds. And once again, we'll see that we don't really see much of a difference. So you can see that there's really no impact on the log buffer, and there is a very minor impact on the write log. So you can see how we're able to completely eliminate any kind of performance issues with regard to the transaction log file behavior and the write latency on it. And this is essentially what delay durability is all about. So when you enable it, you need to go ahead, and I wouldn't recommend using forced, because that would imply that all transactions are asynchronous in nature. Instead, what I would recommend is you go ahead and enable it to allowed, and then within the query start going ahead and putting your commit blocks and specifying in the commit block whether you want to go ahead and make this transaction a delay durable transaction or not. So I'll show you the query for that now. In order to do delay durability at the transaction level, you basically wrap your execution inside a begin tran commit tran, and at the commit tran state, you'll go ahead and specify delay durability equal to on. And that's pretty much it. That's all you need to do to go ahead and tell SQL Server that when this transaction is executed, it needs to be delay durable. And obviously, if you don't specify it, then it'll be treated as not delay durable, and therefore it'll be a synchronous operation. That's pretty much it as far as delay durability is concerned. A lot of people are using SQL 2014, 2016, and I really recommend that you go through your code once more and see where you can implement this, because there is definitely a significant improvement that you can get, especially if you are facing write level operations, write level delay or latency. And definitely something to consider. Even if you don't implement it, it's always a good idea to know where the options are available and take a call about places where you want to implement it. So that's pretty much it for delay durability. I hope you've enjoyed this video. Once again, I am looking to somehow get 1,000 subscribers on YouTube so I can start doing live streams. And if you enjoyed this video, please go ahead and do that. And thank you for watching.